Okay, good evening and welcome on our first Belgian Developer Experience Network meetup. Just 5 minutes introduction about what we're going to do during this meetup, why this community is there. Maybe first of all, we have shift left going on, with a lot of responsibilities being pushed towards developers. Again, and as well, some infra ops security stuff as well, but we as software developers don't always focus upon. And then you have the silos in the organizations, being ops, infra, security. You have the business as well. For example, return on investment is important for the business manager, so you can't refactor always to refactor. Where developer experience group will be playing is in this void. We will be bringing topics regarding security, regarding infra, regarding DevOps, but always with developer focus, developer messaging. And this slide is already outdated because I think AI is a silo that's missing over here as well. And then in the end, it's not the purpose that you as a unicorn will be doing everything, but the thing is that you as a developer will know about what's existing so that you can make choices, knowledge choices with what you know that you can rely upon. For example, what's existing in the infra space that you don't have to code it yourself. And then infra ops people can implement this for you. So we don't expect that you will be able to do this all, and just bring awareness. And maybe for this evening, Glenn, you can go to the agenda.
Yeah, so first of all, Martin has already given a small demo. Second of all, we have talk about generative AI. We switch. So second of all, we have the talk about generative AI. Then we will have a short break. It will be normally around 5, I think.
It will be now 5:30.
Yeah, indeed. So it will be around 5:30, small break of 15 minutes. And then after the break, Thomas and me will present a presentation about DevOps, which will actually highlight a bit of the pitfalls that we see around DevOps these days. And then, I think also probably half hour later, so 6:30, around 6:30, we will have some tapas, and we will have a moment to network with each other and to talk about what we learned and which things we would like to discuss with each other. After we had the moment to network and to talk with each other and to grab a bite and drink a bit, we will be able to throw some axes around, and then we will wrap up and finish the event. So yeah, let's get started.
Then for the second session, we'll talk about DevOps with Thomas Petit, cloud architect, and Glenn Janssens, a DevOps engineer.
It's going to be DevOps, but not the kind of DevOps that I've been seeing actually the past years. It's going to be the DevOps part. So don't think about the whole agile stuff. Don't think about the whole PM kind of stuff. We're going to go on a small journey on where we come from a development point of view, where we're heading to with the present, and of course, what should we maybe take away when tomorrow we're going to tackle the challenges that we see as developers, infrastructure engineers, and everything around it when we do so. For people knowing this logo is just the Jackass logo. Maybe this talk is a bit of a Jackass talk, but okay. We just went away. There's going to be a lot of, let's say, satirical quotes in there, statements maybe that are not fully politically correct, or maybe you feel a bit offended. It's not really the goal. If you feel offended, maybe there's something wrong. You should consider doing it differently. That being said, it's just thinking about where we are basically coming from and what we can maybe do with that new knowledge that we have to do it better. Yeah, there's a lot of generated stuff in there, so I don't need to tell you that some things are just automatically generated. Hopefully, again, don't look at the words, right? Because if you generate images, I think everybody knows that there's just gibberish in the names that are spitted out. So what are we going to talk about? And then I think the easiest way to do this kind of satirical talk is just to talk about the past, the present, the future. So that's basically the three things that you'll see here, right? When talking about past, I always think about Back to the Future. I love those movies, so that's why you see the posters. So again, here we go. What's the talk about? Not so long ago, it's at least something I can't relate to because I wasn't born yet in that time. We had the 60s. Yeah, there is going to be two people apparently, I think, going to be offended maybe in the public. If I say something wrong, anything, interrupt me because, again, not my era, but I think it's Tim, the two Tim Square, right? That is going to be in the public here, right? So, that have maybe some experience in things that I say, so please correct me if I'm wrong. So in the 60s, 70s, we had some interesting changes actually going on in what we today would call development. And that is that, of course, we had the big mainframe era, right? We had the IBMs coming in, filling a room, maybe even filling a building, where they would plan all these machines. Pretty cool because it also introduced some kind of low-level programming languages, if I can say. And it was very monolithic, right? Monolithic in the sense that the fact that we just filled building with it was just a statement on its own. And of course, when talking about developers today, I don't know if the term developers actually ignited in that era. I would rather see them as mathematicians, maybe, right? They would go to these rooms, they would bring in these punch cards. Again, these are relatives of mine talking about these stories, bring the punch cards. They would get a slot to bring in the punch card, bring it in. They made an error, they had to go back, review it. Then, of course, they just put a patch over the small thing that they dotted in. They went back the day after. That's how they did the first kind of calculations and so forth. Of course, the 70s brought away those punch cards. We were really entering data, and that's where it lifted off. And at that time, when we look from a development point of view, was centralized infrastructure, basically, right? You had to go physically to a place, but also IT was actually utility, was something that aided you in some critical processes to do mathematical calculations, for example, and it was not competitive at all, right? It was competitive in the sense maybe that there were only one or two big mainframe companies, but I think we all know them, right? Don't need to call IBM on here, but yeah. So anywho, 60s, 70s, going a bit quicker here. In the 80s, that's already coming up a bit more towards my territory. I was born in that era, basically. So I wasn't known with the evolutions at that time, but you had the personal computer coming in. So personal computer, bringing that compute power basically into your room. That was innovative in certain ways, and the most innovative way was basically you were able to do things locally, to test things, but we didn't have those network capabilities yet, right? So what happened in that time also when we project that ID, or let's say the change in compute, we actually saw businesses giving these kind of PCs to departments. You would get these scattered kind of inconsistent implementation because each department would get their set of computers or one computer to just do their thing with, right? So that's also the moment where we see actually that the departments were actually owning the systems and starting to first maintain kind of systems in that ecosystem, but it was hugely inconsistent. When I look back on the 80s, I always think about these publicities where they, first of all, used Excel. It's the first really version of Excel in an elevator. I think it's a Microsoft page there where they were able to show, look, my department was able to basically do a small calculation on a computer to give a financial statistic towards my board. Interesting time, but it was also a time where compilers, we talk about C, I heard it before, C, C++. Well, that's the era where these first things started to hang on, right? And C and C++, I mean, I think everybody here either knows it or has used it, right? And we heard the talk before, still C++, hugely popular and powerful. 90s, that definitely should, I think, with Tim and other colleagues, that there's definitely some experience in here where the first steps in the 90s using the client-server model were explored. And what did we see in that era? And that's the most interesting part for me, is that first of all, the developers were able to use access to databases. So we were able to actually use databases in a context as developers to actually even do it multi-tiered, right? So we had developers maybe managing more the applications and accessing the database, but you also had the upcoming infrastructure teams managing those databases, managing the underlying infrastructure. And rather than having one PC per department, we actually saw a shift in the 90s where the actual departments were centralizing a lot of stuff, right? So it was not a PC per department anymore. It was centralized infrastructure, teams managing that infrastructure, and developers being able to slowly, in a multi-tiered model, exploit that. On the image that you have here, I took that purposely. You see an IIS server. When talking with the Azure guys, of course, when talking IIS, they still say, "Yeah, the good old IIS." So that's why, I don't know why, but I wanted to have that image on there. So again, at that time, and I think from a business point of view, and that's also what I like to take away here, is that 90s was a bit like a strategic enabler. So when you invested in that kind of technology, it was seen as a strategic enabler for companies, right? It was targeted at growth, and there was some kind of model to find here, where the fact that you were able to tier the kind of model, serve new kind of services towards the external people was really interesting. So what you also see on this image with the client-server database that you have here, right? Multi-tiering. Then the 2000s, that should already come up more to everyone's alley, I think, or at least what I see is this is the kind of stuff that I've still, let's say, seen and within an enterprise context, because I came in touch with it. Maybe not the newest developments, the first developments, but at least I saw maintenance stuff coming towards my way when I started my professional career. And that's the era where you actually had the enterprise middleware. When I talk about enterprise middleware, I don't know why, but I always think about ESBs, but of course ESBs is just a small part of the middleware stuff. There's definitely GEE that we know. And the thing that you have here, WebLogic, WebSphere, I don't know if people know that kind of technology still. Yeah. Resource hungry a lot, configuration heavy, love it. Yeah, there was a lot of work in just maintaining those stuff, right? And that's also the era of where you see that actually we were maturing. That model of the tiered model was actually maturing out, and developers were actually getting more tools in their hand to actually use that kind of stuff. They had these dependencies that they suddenly needed to manage, large frameworks. That's what you see on the left on this image. And of course, applications became more complex, way more complex. The fact is that while the applications became more complex, also the underlying application service became more complex. And that's what we see on the WebLogic and the WebSphere part. But of course, here in that era, it's interesting to know also that companies were actually shifting away from the fact that IT as just a thing you should maybe do, is that this is a central part of your investment as a company. Suddenly there in that era, 2000 was no debate anymore. 2000 was an era where you needed to do some things with IT, and in this case, enterprise middleware, to do your business, right? So that's an interesting shift that we already see here also. And of course, it became more complex, became, let's say, more difficult to maintain. That's also what I saw, because it's more towards the end of that era where I first came in contact with a lot of these things. You saw a lot of maintenance. Maybe it was just edging already off, but I often got into projects where I just needed to do it with that one WebLogic still floating around that needed to be migrated, but nobody dared to touch it. That's basically the kind of that's experience that I had with that technology. Now, the interesting thing is that I put the words here like Mule ESB. It's not MuleSoft. It's the predecessor of this, right? The concept of ESB, the fact of centralizing these connectors, these integrations. There was some interesting thought already in there, and we'll see later on where that maybe that idea already pops up again in a different kind of form, right? There's a small intermezzo that I'd like to take before jumping immediately to 10, and then of course going to the AI stuff. But the 2001 was the year of Agile, and I often like to refer to it, and maybe people hate me for it, but was the idea of Agile where it was still pure, right? The idea where it focused on iteratively, customer centricity. I mean, all spoke words because we came from a enterprise middleware layer where there were things becoming more complex, and suddenly there was the idea of to bring that closer back to business. And we also saw a shift when you see the articles in that time. There was a brief moment, at least from what I could read and the books that I've read there, is that there was a brief moment where business actually embraced, together with IT, the people working, that it should be something that embraces end to end, and not like we maybe see today, some kind of certification program that you should do to do your work better, right? So for a brief moment, we saw that change being introduced, and there's also that cultural shift that we have in that area, right? 2001 already introduced that, and I mean, there's really some good thoughts in what's going on. Interestingly, there were some gaps within Agile, gaps where basically we talked about faster, more iteratively, but it was still a bit disconnected with the operation part, right? How are we going to actually do it more iteratively while also bringing that idea to the operation side? So there was disconnect also with infrastructure at that time. So in 2008, that's the time that we actually see DevOps, the idea of DevOps picking up, fixing let's say, filling in the blanks is maybe the better word of what Agile left behind, and also giving developers more control over the operational stuff, being able to deploy yourself, that idea of being able for you as a developer to push on a button, push on a pipeline, and see the code going live, rather than talking to that infrastructure guy sitting over there and then please deploy that artifact for me. That was already a mind shift, a really nice one. Yeah, so DevOps was born basically, and that's what I wrote down or remembered for myself as a way of actually fixing a couple of blind spots that we created during the Agile mind shift. And of course, when talking DevOps, we actually refer to, again, more the part where we want to streamline the operations. So it's also talking about CI/CD, standards IT processes, where we want to control the way we work with code, the way we build code and deploy code, right? To integrate that seamlessly. And again, now that we have that evolution, bringing everything more closer, right? We're be able to streamline stuff, or at least that's what we can see towards the history. You can also see that trend now that we optimize the way of deploying, integrating. You can see the idea, I think it in 2014 that I saw the article of Martin Fowler. It was an idea where microservices, the thing, I think there was a mind map later, still a hot topic. I mean, it's 2014, the idea was spin like microservices. Interesting idea to solve more complex problems where we want to have flexibility. So there were specific use cases even highlighted in that. And still 10 years later, that topic pops up as an interesting one. I see it on each conference. But the idea was actually born, and you can see that it was more an evolution, made logical sense. Now that we fixed a couple of issues, the monolithic part was getting better under control. We had the idea popping up microservices, right? Being able to push towards more modular infrastructure. That's definitely a thing that we saw. And of course, Spring Boot, also a framework. We of course now have Quarkus around also in that ecosystem. But the ethos of Spring Boot, for me at least at that time, was like, yeah, now I can ditch the GBoss stuff. I can ditch the whole dependency frameworks. I just don't want to deal with that anymore. I just want to deal with code. And that was for me a revelation, like, this is the thing I want to do. Focus on code, make it minimal. isn't it? The Spring Boot stuff is not tightly dependent on microservices, but of course it helps, because if you wanted to do microservices and you had the capability to actually make small deployable units, make also single binary artifacts, an Uber jar, that kind of idea actually was born in that era for me. Virtualization, but it'll pop up later. Yeah, indeed. Good point. So here, what we actually see in that era also is that companies in the 10s were actually focusing more on market diversification through technology. You actually see really tech companies, or companies where you would maybe say these are traditional companies with a typical business model. You actually see here the tech pop-ups also popping up. So differentiating through technology and not through competing models on better pricing, new features. No, purely on technology. Really interesting times, because we were able to actually develop faster. And the complexity, of course, and that's maybe something I would like to highlight, certainly when I hear microservices these days, which we'll pick up on later, is that the complexity actually grew, right? Suddenly you had to choose between different kind of deployment models. Is microservices still the best thing to do? Where should you use it? Should you use JBoss still? Maybe it's still interesting in some cases where you need that large compute, certain types of, let's say, requests that you need to be handling, or maybe you just need something lightweight that fits perfectly in that model. So you had to think already way more about which model to use and where to use it, right? The fact that, for me, the frameworks, GE, the JBoss, are still around says something, right? Says still something. So then, of course, I won't highlight the virtualization directly, but of course, it found place in that 10s, and then the virtualization was a key pivotal moment also towards things that we saw in containerization. Virtualization in the era before already kicked off, but when you see at containers, and then later on also micro VMs that you see popping up, I think in 2018-19 that I saw, so in the 10s there, you see that whole virtualization move, and of course containers fits in that part. So now we're not only able to make our application smaller using frameworks like Spring Boot, but we're also able to miniaturize our infrastructure using containers, and later on using micro VMs, also cool development. So it empowered actually developers to do way more at a larger scale, way more larger scale. And we didn't only have the, let's say, the containers here, Docker, of course, being the first in that, let's say, big idea. We also saw the serverless ID popping up, right? I remember really well that I was just so happy that I had my first Lambda. I had the first version of the Alexa Echo. The only way to integrate with is using a Lambda, so it was a no-brainer, first contact, and was just cool. I can just package my code in a different way. Don't need to care about all those details. But again, choices. All kinds of choices to make. The infrastructure as code is also a thing that we saw popping up within 2010. So referring back to the WebLogic eras, where you just need to click through the GUIs and then complain because it just crashed, the GUI crashed, and then you need to reboot the GUI to be able to just do your deployment, that kind of crap. Now suddenly you get tools like infrastructure as code to be even making your infrastructure and then deploying your stuff on that infrastructure. So really cool evolutions, but again, choices. You make choices, more choices. And of course, these days, when we look at companies and we're confronted with this concept, of course, in day-to-day as developers, we have these complex systems. They were already complex to maintain, and they just become more complex. Now, of course, you could say like, yeah, but public cloud fixes that for us. But have you seen the amount of services that you can just choose from? I mean, it's like these days going just to a store to get a jeans. For me, it's even just difficult to say like, I just want the same jeans with the same color. Then you get like 100 choices, right? And you had that same kind of paralysis actually on the whole stuff going on in 2010. So the agility certainly came at a cost. And I think developers for us these days, it's like even coming into discussions that we see still today, where we actually need to make choices. But we can be happy. There's a moment where we saw before where we had just a room where you got in, where that vendor, the IBM mainframe, just decided that's the way you will work. It's that way. You will come with that kind of punch cards, and that's it. So we had flexibility. I think just knowing from where we came, that's a huge thing that we have here, right? And I just copied it, Jeremy. I don't know if you already patented it, but I call it the era of III. It's the era of III. I don't know where this is going yet, right? I know there's certainly good things in there. I think we had the previous talk. There's still cool things coming up. I recently talked to a developer. I came from DevOps also. Said like, I have a cool plugin. Now I don't need to go to my Jaeger instance. I don't need to consult the tracing metrics anymore on Grafana. I will just run it on my IntelliJ, and the LLM model will just, let's say, consider all the traces coming out of it, and it will just do the performance detection from right off the bat locally. So I can check if my application will actually introduce new latencies or misbehaviors. And I was like, really, that's cool. So you actually don't need that big infrastructure, fully automated platform. You can now do it on your local machine. And actually, that's the whole reason why we put up the tracing, the metrics all there, to make it more visible by bringing it more towards your computer, by bringing it more closer to your, let's say, shift left. You were actually able to filter out those issues. So why do we need the 24/7? Every trace needs to be logged. Maybe that doesn't need to be done anymore. We can just make samples like every 5 minutes to see if the tracing is still okay, because you already did the testing up front on your local machine to see if your application misbehaved or not. So really cool stuff. But yeah, there's a steep learning curve, right? And I think we heard in the previous talk a lot about applicatively, which is really cool. Myself, I've been last 4 or 5 years more interested in the infrastructure side, so Kubernetes and everything surrounding it, and also virtualization. So for me, of course, I put here the 4 big public LLMs that you, of course, see, the public services that you probably consume, the Geminis, the ChatGPTs, the Claude, that kind of stuff. But there's also NVIDIA empowering all that stuff. It's incredible. And it's so easy just to do and to set up. I was thinking like, how difficult must it be? I need to know how the Linux kernel actually will pass through all that kind of graphic card information. I'll need to multiplex even, because I have a simple graphics card. I can't use it and share it between different kind of containers. How difficult will it be? And actually, in a couple of days, I was just able to plug in the card, configure the Linux machine, set up the operator using an NVIDIA stuff that you have here, even multiplex it, because there was a talk where it just talked, you can just software-wise share your graphics card over different kind of containers, and it just works in a couple of, let's say, days, right? Between hardware installation and this. So I think there's a huge shift where we actually are able to do things more efficiently and faster. Even just integrating it becomes easy. But of course, complexity just rises. And I think one of the things that I'm always worried about, because as a tech geek, maybe more on the lower side on infrastructure these days, but do I fully understand what these machines are actually spitting out, right? And that's always the thing that you try to do. And by the end, when you understand it, the next era is there. And then you already start with the next part, right? By the moment that you think, yes, I know how it works, either you're still in COBOL, either still or you're already in the next chapter and doing the next thing, right? So, and the other thing that I see, and I see a shift, and that's a shift in 1 year's time that I've been seeing, and then that's the graph on the left side here, it's the energy consumption. You see, of course, these specific processors being made. We also talk about security, of course, but I think there's an interesting statistic where normally in 2030, 9% of our energy consumption will go towards AI applications, AI-driven stuff, whatever, 9%. I mean, that's huge. So there will be developments on that side also. We will maybe have more developments where maybe your full computer is actually a GPU and that's it. I don't know. A really cool stuff, and probably we'll need to learn how to use that stuff too, and have a new model, not a LangChain, maybe something else, right? But anywho, that's a full encompassing story about the past.
All right. First of all,
Yeah, I don't know if the mic works.
so first of all, when I saw Thomas was making his first slide, the mainframe, I actually thought like, what are we going to tell them? Where are we gonna start? Because I'm even younger. I'm from the 90s. But actually, I must say, when he was going through the first dry run, I was actually like, okay, this is actually interesting. I've never really thought from up to there to where we are now, like what happened, what transpired, how did we really get there? That we moved away from the big mainframes, that we went to client-server model to make the process more efficient, and that we introduced both frameworks, DevOps, Agile, and containerization to make everything go smoother and deliver much quicker. So that actually was really interesting, just to have like a quick recap and to see like, okay, so we got here at the present day because of all the things that we experienced in the past. But now we are actually quite in the shit show, I think, because I've seen a couple of problems that were highlighted during those times. And I think to myself, did we actually really solve all those problems, or did we just iteratively go over each problem and solve them at that time? So yeah, I think let's go through it together and let's see if we actually solved them and if they can't really appear anymore. But before we do that, why should we actually care about that? I have a dream that one day I wake up, I start up my laptop, I go into my application that I was creating yesterday, and that actually all my builds are still running fine, that there are no false positives that suddenly popped up where a build is failing and nothing has changed. But I believe we're not there yet. There are quite some things that still have impact on them. There are quite still a lot of things that have impact on my work as a developer that I don't really have any impact on right now, and that someone has to do for me. So I'm actually quite dependent on several teams, people, and departments that need to guide me. And first of all, let's start actually with the mainframes. So did we really get rid of all the problems that mainframe solved? I'm not sure. We went to cloud providers because they offered solutions to problems that arise. They offered more scalability. They offered compute on demand and where we needed it. And we could also focus a lot on innovation. They brought more and more into that, and they followed along the latest open source and technology, and they were evolving together with us. But I feel nowadays that sometimes we need certain skill sets or certain expertise to connect all the dots that are already in there. So did we actually solve the rigid infrastructure part that was in there before? Or did we just create a new? And do we have a problem there that it's going to be ever evolving, and at a certain point we won't be able to return? A second thing that also Thomas mentioned was that the developers could focus on code, which was great. We could finally just leave everything behind and just focus on the thing that we like to do the most, focus on writing code. And what did the companies do? Well, some of them designed a central DevOps team. They learned about the DevOps culture. They learned about certain things that would really benefit them and that would really fill in all the gaps that Agile left for them. But somehow that's got all put into one team, and now developers can just throw it over the wall to the DevOps team, and the DevOps team will solve all the problems. If their code doesn't behave or doesn't work that well in production, I guess the DevOps team will solve it. I guess they'll have all the necessary tools, expertise, and skill sets to do all that, and that a developer can just focus on delivering the code and have no worries about ever doing anything else, because there is no self-service needed. We just have the team that can take care of anything, right? Another thing that we do efficiently is share information these days. We have Git, I think we all use Git, or hopefully we all use Git to do a big amount of our daily work. And it's really nice because it makes it quite easy to find bugs or issues or things that someone did wrong. And there is just a label on it with a name of the person that put it into it. So we can just blame that person for doing it wrong, or just blame that person for putting it in there. And we don't ever have to worry about finding the root cause or how we can fix it in the future. We can just point the blame to the person, and GitOps even automates that process because it automatically gets pushed to where it needs to be. And we can automatically see that the person fucked up and make him responsible to fix it. I always say automation is key. I think in the ever complexing or ever getting complexing environment that we are in, it will be difficult to do anything if you don't automate certain parts of it. Like, for instance, I'm working in a cloud provider, I'm working on premise, I have CI/CD tools, I have a lot of tools that are in there. I probably don't even know all the tools that my company is using, but automation will help me to do and work a lot around them. But I don't have to worry about my application only right now. I also have to worry about my automation, because I'll probably automate something, maybe something simple, maybe I'll write a script for something, maybe I'll create a pipeline for it. I will put it somewhere where it can run, and it will probably work fine. I'll probably never have to look at it again, and it will continue to be worth the investment that I put into it, right? Yeah, I'm not sure. I think I mostly have to maintain quite a lot of my automation that I've already invested in. So, you know, it takes time. You don't really have to really worry about investing only the time to automate it. You also have to worry about keeping it managed, keeping it maintained, making sure that it can last in things that are evolving, things that are getting more difficult because we are putting new technologies into it, because the landscape is changing. So it's something that we have to worry about as well. And if we go a bit further into that, then we also have to improve it continuously. We have to hold endless meetings of what can be done better, of what can be improved. We have to create elaborate reports of what we have been doing in the past, where we see some gaps. We have to track a lot of metrics that show what can be done better. Like, for example, I mentioned Git. You can also see like how many lines of code a developer created. You have Sonar to deliver a lot of feedback on what we are doing, and there's so much. It's only getting more. There's only more feedback on what we have to improve. So the thing is, are we going to keep improving everything? Are we going to never look back on what we improved in the past and what we're going to do in the future? I don't know. Sometimes it's a bit hard, you know, because there's a lot to do. If it works for one team or one project, will it work for another team? We have to standardize it as well. We have to find some new approaches to get everyone on board in the standard way of working. So yeah, we continuously need to look at everything and continuously need to make sure that everything gets better, which is not that easy to do. And then, like Thomas was mentioning as well, Agile versus DevOps. DevOps was there to fill in the gaps of what Agile didn't deliver, or where Agile had a couple of missing blanks. But we feel like DevOps actually went a bit to the dark side, right? They started to not really fill in the blind spots, but like it started to mingle a bit. And I'm going to explain it a bit more better with an example. So imagine if Agile is a rebel alliance, like they move in small compartment teams. They can like create a plan efficiently. They easily gather information, and they can like quickly use that information to get into a new plan and to adapt around it. Like, let's say that they are going to take over an imperial base. They can do that very efficiently because they work that way. Another thing is they have very good collaboration and communication because they are used to work in separate teams that communicate well with their leaders, and they really involve their stakeholders to do that. But if we compare it to the Galactic Empire, if you compare it to DevOps, it's more like the Galactic Empire, but in a good way. They make sure that everything is standardized. They make sure that they can easily deploy all their star destroyers efficiently because they focus on speed. They can focus on every time creating the exact same artifact or model, and in this case, a star destroyer that will be working perfectly. It will have the right dimensions. It will work the same every time, and it won't have any bugs in it because that's already worked out. They also break down silos because, yeah, the Empire has different departments. They have stormtroopers, they have TIE fighter pilots, they have everything, but they all work together to a common goal. And that's a bit like DevOps, right? We try to break down those silos, and we try to have a collaboration between development and operations, and we try to foster that collaboration and share the responsibilities. I thought it was a cool thing, like, to compare them a bit. Like, it's not, DevOps is not really evil. It's actually a way to have better standardization and a better approach to it. So I hope I could like share a bit of light on that. And then if we look at shift left, you see Thomas edited the slide a bit. I was not aware of that. Trust me. It actually really started with someone saying, "You build it, you run it." I think it is a quote from some time ago already. Like I said, I've only been working like 6 to 7 years in IT, but you build it, you run it is actually something that I think I started already hearing like during my first or second year when I was working. And for me, it didn't really mean like, okay, you now have to do it all yourself. It really meant to me like, okay, if you want to build your code, if you want to make sure it has it has, yeah, how do you say it? If it has all the right qualities of a good code, like security checks are there, the quality gates are like to a good standard. And I always thought, yeah, that's my job. I like help developers getting to there, that they can focus on the right code and that the quality is guaranteed. But for some reason over the years, I've seen it change, and I've seen developers more burdened with the responsibilities of doing it themselves, of having ownership handed to them. But what really is that ownership? Nobody is really, nobody can really define it. It probably means that the DevOps team has too many issues to work through. So here, let's hand a bag of ownership to the developers so they can do a bunch of the things themselves, so they don't have to wait on the central DevOps team. But I don't think that's where we want to go, right? I think we just want to deliver quick feedback of the security checks, of the quality of the code, and even of what is happening in production, and that you're able to react on it, and that you can make it better, and that you can put in CI/CD, or you could do it in different ways. But I think it's necessary that the developers don't really are just pushed that ownership. It should be a collaboration. It should be something that we work on together, and where we can really like help each other in and go to where we want to go. And communication is an important part of that as well, because if we don't communicate on where we want to go, then we'll probably end up somewhere where we both don't want to be at. And I think, Thomas, you have something more to say about that, right?
Who's doing shift left? Or yeah, one who's heard about GitOps? Oh yeah, fuck yeah, yeah. Yeah, I think what I've seen lately is actually these things just going bad again, right? Suddenly the GitOps, the idea of GitOps, we saw the same with Agile, we saw the same with DevOps. We just removed the first 3 letters, we just put something new in front of it, right? And then becomes suddenly the infrastructure guy. It's now just called Ops. Never touched any Git in his life. He knows really well how to use probably VM, Vim, the Bash. But you just say like, did you ever use Git? Well, now just use GitOps. Just going to fix your issues. I mean, I've been seeing that trend now going on. There's the FinOps stuff. I'm just not going to go in that part, but there's some interesting stuff going on. We're inventing new terms, and I sometimes need to slow down and think, wait, what are we trying to fix here, right? Did we think about things like feedback loop? How is that going to be represented in GitOps? Yeah, I don't know. That's for the ops to just figure out, right? So again, that's one of these things like we saw with the shift left with the agile DevOps trend, and I see the same thing going on with GitOps, and probably there will be a next ops that I will find in an article tomorrow morning or something that will just do the same mistake again. And of course, we have the term platform engineering. Love that one, right? Gave you the history, fantastic, right? Now it's just DevOps again. Right? I mean, I don't understand how we can even get in that scenario where I need to read the articles that promise me cool stuff, while in reality, I just see that idea of a team sitting there again, which is actually now rebranded as platform engineering, or even better, these are platform engineers. I don't know if it's beneficial for a rate or something. Maybe it is. But yeah, just basically there's a lot of rebranding going on. And if we take a look back in the history of times, again, what are we fixing? Are we rebranding stuff, or are we really fixing things? Because the idea was always pure in the past, right? The idea was there to progressively, iteratively fix one problem, go to the next. But I don't know if we're doing that these days. And there's also the trend going on. I've got a tool for that, right? We have these different kind of stakeholders within the company. There's a developer, there's maybe a DevOps, if you not represented as a team, but a developer actually doing some ops stuff, right? Like the real DevOps ID, pushing on the button, deploying stuff. Yeah, that still exists, I hope. But there's also the ops maybe getting involved with development, knowing what they're trying to accomplish and seeing how we can optimize the infrastructure and the automation surrounding that. And there's each time again some tools, some interactions needed to make that puzzle work, right? The whole puzzle needs to work. And what I see is that there's a tool for documenting. Then I typically need to ask like, hey, are you doing it in Confluence, GitHub, with Markdown pages? Are you just using, I don't know, just straight in the code? I mean, that works for me too. Yeah, and we have a tool for that part. For diagrams, you'll need to go to Enterprise Architect. And for the other ones, you'll need to use an open API, or we'll commit it towards the API manager where you have a developer catalog. I'm like, great. So there's a bit everywhere, right? And there's a lot. So I think we fixed this, right? Yeah, I don't think so either. I see people nodding no. No, I don't think so either. I mean, I think we fixed something. We acknowledged that we want to streamline the interactions. That's definitely a good thing. But we forgot one thing, going back to the roots. Why are these tools there in the first place? Why can't I use that one tool and you use it for multiple things rather than just introducing a new one? So again, I'm a consultant, so I think for me it's interesting because yeah, there's consulting to do on that side, but maybe it's also good to go towards, let's say, the enterprise, the company, or even your manager, your peer, and discuss what's the root of the problem that we're trying to fix here. And can't we do it more simple? Yeah, there's still that sentiment for me that we're not fixing the right stuff, and thus these tools, they need to already fulfill some kind of expectations. I saw the meetings with things like Backstage, and also at Lation side, you also have, I think now with the harnesses, there's all these kind of tools, and they need to fulfill some kind of thing that they will not fix for companies. But suddenly, I mean, developer catalogs will fix everything, right? They will not. And I think that's really important, because we did forget the primary lesson there. And of course, tooling. I had some cool talks when I come in with a kind of map on tools that we have, frameworks that developers are using to empower themselves. They're using plugins. Maybe tomorrow you use the DevOps Genie also in that stack, right? You'll put them on a map. You'll go towards your management. We need yet another couple of tools that need to be integrated in there. And I've seen these days also tools popping up just for sake of tools, and it becomes a bit like the game that I was used to play on Schoolyard, right? Gotta catch them all. I mean, it's that sentiment that I just get. Maybe it's just retro vibes that I need to go back to those times. But again, I see that popping up in the day-to-day stuff. We're just trying to not look back, look forward, look towards the next tool that we can probably use to fix these kind of issues that are popping up, while a lot of these tools are already in front of our noses to fix these things. But it's always easier to just add one other tool, right? So again, and probably I'm bringing a bit of the shit show here. Probably I'm already guilty on a couple of these things, right? I just want to say I'm not a saint on this part. We're just learning through this, so yeah. Sorry up front for a couple of faces that I know. You'll probably say like, "Hey, but you were a part of the problem here, man." Yeah, I was. But acknowledgement is the first part. So that's a bit like, have we fixed the things that we wanted to set forth? I mean, if we look back on the history that we had previously, each time again, we had a problem, we tried to fix it. Did we fully fix it? Probably not. We saw it with Agile, with DevOps. We saw it with the actual client-server model going to enterprise middleware. We saw it going on towards more modular stuff, introducing new problems, maybe not acknowledging the old ones correctly, and adding just more to it. So I typically use that meme also on Teams chats and everything, or WhatsApp. If you see like what kind of fit show is that, I always think about Jurassic Park, where you had that quote of Jeff Goldblum just saying like, "That's a big pile of shit, man." So again, maybe I'm just too cynical as an architect, but that's the thing I remember. Want me to go on, or you'll go?
Feels like we're suddenly in the AA. Acknowledgement is the first. Okay. So, last part, we're gonna keep it short. We're just gonna have 3 takeaways. We've seen a lot of the shit show. We've seen how large actually the big pile of shit is, but we just want to give you like 3 ideas, 3 tips that we can give you, so that we can maybe make the shit show, maybe downsize it a bit, maybe like fix a couple of things, who knows. Something that's stuck by me for a long time now is a talk that was at DevOps World, I think last year or the year before, and it's a talk that some of my colleagues saw, and they came back and they were like, there is this second biggest Dutch German bank, yeah, and they said, we're focusing on 10 tools and we're trying to maximize the output that we get with those 10 tools, and we try to also stick to those 10 tools. And I think if you search for it, you can probably find the exact 10 tools that they used. It was really cool to see that they were actually focusing on only 10 tools and seeing to maximize them throughout their department. Like, if I want to give an example, another thing that I saw or heard some time ago was a company that threw out Confluence and they moved everything to GitHub. So they were like moved everything to Markdown. They used generators, so purely for documentation, right? And they just made everything accessible through GitHub. They created pages. They made sure their analysts, their business could use it, and that they didn't really have to learn anything about GitHub, or not that much, and that they can just use it as their main documentation platform. And you see other things that you can do, like with, for example, GitHub, where you can just centralize a bunch of the things and a bunch of the capabilities that they offer. And if you're also just be a bit creative, you might be able to solve some of your problems that a secondary tool will solve as well. So there's just a lot that you can do, which is focusing on what there is already there, focusing on a skill set that is maybe very a skill set that is very high in your organization. Like, let's, for example, Java. If you have like a really great expertise in your company of Java, maybe you don't have to use, let's say, Ansible to do configuration as code, or you don't need any other tool. Maybe you can just create a Java application with the Genie and say like, hey, we want to do some configuration as code. I'm just spitballing a bit here, but you know, like, if you be a bit creative, maybe you don't have to adopt some random tool to solve a problem that you have. It's something to take into account, right? It can be a bit of a mantra. Just think about this first and then look at another tool. I also like Back to the Future. I also immediately thought about adding it to the slides. I think we can all agree, or hopefully we can all agree, there is no such thing as future-proof. We have to keep evolving. We have to keep in mind of what the problems and challenges are that we want to solve and how we can solve them, and that we don't really look at one technology as being everlasting and still solving all our problems throughout the future, because we probably don't really know all the problems and challenges that will arrive soon. AI will probably be able to solve some new challenges and new problems, but maybe it will also create some new challenges and problems that we will need to solve in the future. So keep in mind, just take a couple of seconds when a new challenge arises, think about it, analyze it. Hopefully, the company where it arises gives you the time and needs and tools to take a look at it. Because sometimes, sadly, we have to go fast and it all needs to get done rather quickly. It's just something to also be mindful of. And then the last thing, and I think everyone here came to this meeting to indulge in the last step. Exchange problems and share ideas. Go to communities, check in with your stakeholders, check in with colleagues, with friends that work in the same area, or maybe even not in the same area, that can like pivot your ideas, and like maybe you hear them telling something new that works in their area, and maybe you can take it with you. But yeah, I feel like there is a lot of sharing ideas and sharing use cases, sharing problems, and how someone solved a problem or solved a certain challenge that they had at their company, or even solved new things that they were able to solve with AI. It's really interesting just to go to these communities and like have a talk with people you don't know, and like see like how they think, how they visualize certain problems, and yeah, we can all learn from each other. I think that's the most important part I really wanted to share with this last slide. And that is it. Hopefully we can have a nice chat right now, drink some beer, have some pizza, and get to know each other.